Hi, welcome to part 8 of chapter 5. So from this section, part 8 and part 9 and part 10, we are going to go over mathematical details of molecules and its masses. So starting with this topic here, where we are going to identify molecular or formula mass. We discussed some of this already in chapter 2. At the end of the chapter 2, we discussed molecular mass and moles and how to identify number of molecules. Here we are discussing again because we discussed some of the related things in this chapter. We just identified molecules. We just made molecules, ionic molecules, covalent molecules, and because we are so familiarized with the topic, we are just using it as an advantage to calculate its masses as well and revisiting the topics that we just discussed, just to know what is the ratio of the atoms and all of these. Again, this is all preparation for chapter 8, where we use all of these fully to work on chemical reactions, which is the ultimate goal when you try to make any compound. Okay, let's look at this easy topic. I literally mean that it is an easy topic because identifying molecular mass is basically trying to collect the individual atomic masses of all the elements that is present and present the total number as the molecular mass. And how do you calculate a molecular mass is first you identify a molecular formula and you identify how many times each molecular formula is present, and then you identify its each element's atomic mass and you multiply those many times to get the molecular mass of water, to get the molecular mass of any compound. Let's look at this example. Molecular mass of water, it contains two hydrogens, so you need to multiply atomic mass of hydrogen with the 2, and because it contains only one oxygen, you don't have to multiply the atomic mass of, excuse me, you don't have to multiply atomic mass of oxygen with anything. Excuse me. So if you solve for math, you would end up with the molecular mass of water. Isn't it easy to perform? Uh, uh, because these atomic masses came from the periodic table, atomic masses of each individual element. Sometimes they look fractions because 1.008, 16.00, because they were the average atomic masses that were calculated based on the natural abundances of its isotopes. Like oxygen has isotopes of deuterium and tritium. Oxygen also has isotope of oxygen 17 and 18. So based on those abundances, so we multiply with those fractions and its molar individual atomic masses, and we come up with this unique number based on their abundances. So that's why they just look fractions. And please get comfortable with referring molecular mass as molecular weight. It's the same thing. We just have multiple words to express the same thing in chemistry. Molecular mass or molecular weight are the same. We're saying molecular mass and formula mass. Uh, Molecular mass is the word that we use for covalent compounds. Not that it's going to make any huge difference, but it's like common courtesy of using a specific word for covalent compounds. And also for ionic compounds, we use the word called formula mass or formula weight. Whenever you say this formula mass or formula weight, we are trying to specifically say that you have an ionic compound. Again, it's a common customary, common practice in chemistry, but the result is going to be the same. Even if you're calculating molecular mass or formula mass, it's the same technique that you use. You identify how many of the atoms present, you multiply those many times with its individual atomic mass, and you present the answer in atomic mass units by cumulatively collecting all the individual atomic masses. Let's practice one or two problems. Let's see, the problem it is asking for us it is asking us to calculate either molecular mass or formula mass for these compounds of propane, lithium hydroxide, and barium acetate. Okay, I see two easy examples, and there is one challenging one. You just need to know how to decode problem C. I'll help you do that. So what is your plan is going to be to identify the molecular mass or formula mass. First, you need to know how many each individual elements present. Like in C3H8, like you have 3 carbons and 8 hydrogens. You need to identify that. First, you need to identify how many different elements present, and then you need to identify how many times they were present so that you can multiply the atomic masses of those individual elements with those many times to get the eventual molecular mass or formula mass. So 3, you need to multiply with the atomic mass of carbon, and 8, you need to multiply with the atomic mass of hydrogen. If you do that, you would have the molecular mass of propane as 44.09. Excuse me. For problem B, lithium hydroxide, you have 1 lithium, you have 1 oxygen, and you have 1 hydrogen. So all you need to do is, because they were 1, you don't need to do any further multiplication. So you just need to collect the atomic masses of lithium, oxygen, and hydrogen, and combine them together to identify the formula mass of lithium hydroxide. Now comes the challenging molecule, barium acetate. Here, this is the tricky part that students miss it. Whenever you have a polyatomic ion, and if it is required to present multiple times, you use the parenthesis. Now, to identify how many of each one of these is present, this parenthesis 2 is saying that you need to multiply 2 with each one of these elements that are already present inside. Inside, there are already 2 carbons, and you are multiplying that 2 carbons with 2, so you actually have 4 carbons. Inside the parentheses, you have 3 hydrogens, but outside of the parentheses, you have 2, which means in reality, you have 6 hydrogens. Inside the parentheses, you have 2 oxygens, but outside of the 2, you have, outside of the parentheses, you have a 2, so you have 4 oxygens. And there is no parentheses around barium, so you just have a barium, single barium. Okay. Gosh, I just scratched myself pretty hard. Gosh. All right. So now practice is similar. To identify formula mass for this, identify the, from the periodic table, identify the atomic mass unit for each one of the single element and multiply those many times to get the formula mass of barium acetate as 255.4 atomic mass units. That's all you need to do. Only thing you need to worry about is make sure you correctly multiplied for polyatomic ions. If you have a parenthesis, make sure you multiplied them again to get these, 4, 6 hydrogens or 4 oxygens. If you make a mistake, you would end up with wrong molecular or formula mass. I will see you in another part of this lecture.